Okay, I just sent that.
Okay.
Did it pop up?
Not yet.
Okay, your email is SAFG.
Wait, what?
What's your email again? Your Gmail?
SAG.
SAG?
Like, the S is an S as in Frank, A as in alligator, and G as in giraffe. And ERGREN. I'll go through that. At gmail.com.
Okay, I just sent it again.
Okay, I'm not seeing it yet.
I sent it like 3 times. I don't know why this does this every time.
Oh, there it is.
So weird. Seriously, I had to send it that many times.
Okay.
Can you hear me?
Yes, now I can hear you.
Awesome.
Okay, better.
Okay, I'm gonna try screen share because I know last time I kept making it crash, but hopefully this time it won't. Okay, cool. Now I can actually show you what I'm doing.
There you go. I get 2 of me. How good.
There you go. Okay. I'm trying to figure out. Oh, there we are. Just kidding. What am I doing? Okay. We want to go ahead and start with a prayer.
Yeah.
Okay, cool. You want to say it?
Yeah, I can do that. Our dear Heavenly Father, we're grateful that we can come together today. We're grateful for the opportunity to be able to learn math and to deepen our knowledge. We ask at this time that we may be able to do well on our quiz together, that we may be able to understand the principles to prepare for our test and to be able to gain more knowledge. We love thee, Father. We're grateful for thee and for thy Son, and we say this in the name of Jesus Christ. Amen.
Amen.
All right.
I was really actually happy to find out that this is just a review.
I know. Super nice.
Yeah.
Well, wait, don't we have a group quiz together?
Yeah. Yeah, but it's all stuff that we already know, so.
Oh, okay, okay. I was like, wait, I thought we had one.
Yeah, we do. Okay, so the first thing he wants us to do is, well, first off, like, is there anything that you had questions on from the preparation?
No, I don't think so.
Yeah, I think I'm fine as well. Okay, so he wants us to find the 6, that's not it. the 6 trigonomic ratios in simplified form, given a equals 3 and b equals 7. So I looked at this and I thought that like he was talking about, oops, what's going on here? Like if you look at the right triangle,
Yeah.
you have one side that's A, one side that's B, and one side that's C, and like
Yeah, that's what I was thinking. So then you do the Pythagorean theorem to figure out C, and then you'd find sine, cosine, tangent.
yeah, okay, good. Because I stared at it for like a good 5 minutes, and I was just like, I hope this is it, because I can't think of anything else this could mean.
Yeah, that's what I was thinking too.
Okay. Nope, B is not 3. B is 7. Let's see. So that's what? That's 9, 49.
Yeah.
Let me see. That's 58.
Does 58 have a square root? I feel like it does not.
Yeah, it doesn't.
I'm pretty sure it doesn't.
Okay, so sine would be, see, that's opposite over adjacent.
Yeah, what angle do we take it from then?
I
You know
assume
what I mean?
we just take, yeah, from A.
From angle A. Okay.
That's awful A.
So that would be 3 over 7, right?
Wait, wouldn't it be 3 over the square root of 58?
Oh, yeah, because it's opposite over hypotenuse.
Yeah.
That was
Okay.
better. Yeah. So 3 over square root of 58. Sorry.
How many?
Hey, I'm in my video chat thing. It's okay. Okay, are you coming home and then going to work? Okay. Okay. Sweet. I'll see you soon. Okay, love you. Bye. Sorry.
No worries.
Okay, continuing on. You had cosine equals 7 over square root of 58. Is that what you have?
Yeah. And then tangent is opposite over adjacent. So that'd be 3 over
3
7.
over 7? Yeah. And then I don't care if you write them out. We can just say them really quick if
Oh,
that's easier.
okay.
Because all
And
you
then,
do is just flip them.
yeah. Okay. And then the second thing he wants to do is graph all parts of these two. And
Okay.
not what I wanted to do. Okay. So looking at this, you have A, B, C, and D.
Yep. So the A is going to be making an inverse.
Yeah.
And then the B, is that just 2 pi then?
Yeah, it makes a period. Well,
Well,
what is
because divide by 2 pi, so it would just be 1.
yeah. Isn't the period for tangent like only pi though? I thought it was.
I don't remember.
Okay, one sec. I'm just gonna look back at my notes real quick.
Okay.
Because I feel like it was different for tangent. Oh yeah, okay. So the period for tangent and cotangent
It's
is
just,
yeah, it's just pi.
oh, okay.
Period equals pi. And then c is equal to negative pi over 3.
That moves it to the right.
Yes. And then d is equal to 2. That moves it up.
Moves it vertically up. Yep.
Oh no, it's gross. Okay. So okay, so the period was pi. Is pi. So we have to move it over pi over 3.
That'll be our starting place.
Yeah. Okay. Just trying to think of how to like graph this out.
I know, I hate graphing them. So we know it's going to be inverse.
Yeah.
So the tail end is going to start up on the left side above the x-axis, and then it will come down and then switch to the right side. Does that make sense? Kind of like a
Yeah.
smooth line. I just have a hard time knowing where to plot the points. Like, I know what they do,
Yeah.
but I have the most trouble doing that. But I guess if we just start at point 0, 0, that's where tangent hits, right?
Yeah. So it should start there, and normally it goes up. But for this one, because it's inverse, it'll be going down. Starting at pi over 3.
So we'll go to the right, pi 3, then go up 2.
It's right there, and then let me see, where would the asymptotes be? Because normally it's at pi over 2. But because we're moving it over pi over 3, it would have to be whatever pi over 3 plus pi over 2 is.
Would it just, because it moved over pi over 3, would it just move over, like, again?
What do you mean?
I'm looking. Hold on. Would it just go, like, is it just at pi, or is it? I'm trying to decide. I don't know.
Yeah. Okay. Let me think. So normally it's because of how I drew the graph, we can't necessarily see pi over 2. 1 sec. I'm gonna pull up Gizmos. What? Okay. Gizmos, where are you? Okay. So that's 2. See, their asymptotes are right here. Well, actually, no, because since there's no change in the period.
The graph doesn't look, well, it does.
Yeah, because they have theirs at right there. Yeah, it looks pretty much the same. But if we do, since normally the asymptote is at pi over 2, and we're shifting it over by pi over 3, pi over 2 plus pi over 3 is 5 pi over 6.
Okay.
Go ahead and see if that's it. Okay. So,
I think that is it, actually.
okay. I just have to figure out how to graph that.
I think it would just be like right below pi because 5/6 is almost 1. You know what I mean?
Yeah. So, like,
So like somewhere in there. Yeah, like something like that.
okay. And then it goes down.
Hmm.
And the other asymptote would be over 2 minus pi over 3.
Okay, tell me how you found the asymptote again for 5 pi/6.
So you take, so normally the asymptote is a pi over 2 because
Mm-hmm.
that's when, so pi over 2 is when tangent is equal to 0.
Right.
Um, and since you shift over the whole graph to the right by pi over 3, that includes the asymptotes. So
Oh,
you just do pi over 2 plus pi over 3.
okay, that makes sense.
And then the other one is pi over 6. So that'd be right here. Oh, wait, that one is.
Wait,
Should be. Oh, wait. No, yeah.
would it be negative pi/6 though? Does it
I think you're right.
Because you have pi/2 minus pi/3, actually.
Yes, yeah. You are so right. So right here.
Well, maybe.
I mean, that makes sense if usually
Yeah,
the
it
other
would just
asymptote.
be both ways. I think that is right.
Awesome.
Oh, so number 2.
Okay, so I'm just going to analyze this real quick. Whoa, where did everything go? I'm having technical difficulties over here.
That made it easy.
Yeah.
And this is all on your iPad?
Um, so I have like, it's not an iPad per se. It's like, I don't know. It's not exactly a tablet that you would think of. It's just this piece of metal that tracks where my pin is. And
Oh,
so, yeah, pretty nifty. So with this one, we'll have to get B out of there. If we just divide this by 2.
so wouldn't it just be negative pi then for the period?
Um,
Oh, wait, no, never mind because you pulled the 2 out.
yeah. So that'd be, well, what is pi over 2 divided by 2?
You would multiply. It would just be pi, I think. Because pi/2 divided by 2 would mean you'd multiply it by 1/2. Well, so it would be pi/4,
Okay.
I think.
I think you're right. Um,
Well,
yeah, it's pi over 4.
okay, cool.
Okay, so that would be uh, and then we have the shift over pi over 2 to the right.
And it goes down 1.
Yeah.
And it's also the inverse.
Yes. Okay. I'm trying to think of how we should divide this up. So pi over 4 divided by 4 is pi over 16. But because we're going to be moving it over pi over 2, okay.
I think you could just do pi fourths, pi halves, pi 3/4, maybe something like that.
Wait, what?
Just how you're setting it up. You're doing it exactly what I was saying.
Okay. C pi 4s, pi halves. That's a 6. Okay. Then okay. A couple more.
I think it's fine right there. I don't think you need to go higher.
Okay. Let me see. So, what?
Sorry, I yawned.
Oh, okay. Oh, I guess I really didn't need to go up any further. Oh. Okay, so if we're moving it to the, oh wait, it's the opposite way. Because it's a plus, it'll be going this way.
Yep.
Alright. So the left by pi over 2.
2 and then down 1. Right there.
And then it is stretched by 2. So
I always have a hard time with that.
yeah, I always have to think like, what is this other one? Okay, so it will go in between 1 and -3. Okay. Since the period is pi over 4,
So this is where I get thrown off when the period comes into play.
yeah, it's like how far does it go? Because it goes, we know that it will go down like this, but like where does it, is it a
Well,
point?
it's just gonna mimic it on the other side.
Yeah. So does it go to,
I think it goes to negative. I think it plots at like negative pi fourths, -3, and then goes up.
like, oh wait,
I think you have the general idea though.
yeah, like that, kind of, can't see that.
Yeah. The
Yeah.
only thing I can think that it would just end at pi halves and 1. You know what I mean? Because it,
Okay.
like the other one, I don't know. Maybe not.
So would it end like here?
Uh, no, I think you have it right actually.
Okay. I can go ahead and just check. See what it actually looks like. Let's see. 2 sine over
2x plus pi and subtract 1.
Okay. So, no, I should have kept this in there.
He also, so are you on, go to the instructions for GHOA page.
Yeah.
Look at the very bottom. Scroll down. And it says
This one?
week. Yeah, click on that.
Okay.
Because I just clicked on it and I was just looking at what he did.
Oh. Okay.
So that's what he did.
Hmm.
And we were pretty close.
Yeah.
I just don't know how he got the other side. Like, I understand the negative in quadrant 3, but I wasn't sure about the other. Because our first plot was plotted correctly.
Yeah. Okay, so what I'm getting, okay, I see it. Because, so, maybe not. I'm just struggling with the period.
That's what I'm struggling with.
It goes from here, here. Oops, not there. Here. Guess I just don't see how that works.
I don't get it either, what he did.
Okay. Oh, you know what it is? I did. Okay, so the period isn't pi over 4. It's, I was wrong about the period. It's 2 pi over b. So that'd be,
2 pi?
yeah, it's 2 pi over b. That means that the period is just pi.
Oh. Well, that made a difference.
Yeah, yeah, it did. So it would be, yeah, it'd be negative pi over 2 over 2 pi over 2. That makes sense.
Yeah, because then it's only going over pi each. Yeah. Okay.
And yeah, then of course it would make sense for the middle one to be here. Okay, it's all making sense now. Okay, cool. I think that should be it. Okay, so do you get it? Because I think I've got it.
Yeah, I think I do.
Okay.
I was just confused because of the period in the beginning.
Yeah.
I like looked
My
at his
bad.
graph. I was like, I'll just check his graph to see. And then I was like, that doesn't make any sense.
No. Okay. So next one is find cosine given that sine is equal to 1 over 4. Okay, so when I saw this, I just assumed that it was like the triangle thing again.
That's what I'm thinking.
See, so if sine is equal to 1 over 4, that means that the opposite, I'm just going to assume that they use the angle here, or for the angle that they're referring to. It's 1 over 4, like that. Which means we've got to find b. z-adjacent. And we would just have to use the...
That's what I did. I did 4 squared. I did 1 squared plus b squared equals 4 squared. So then I got the square root of 15.
Wait, what? Oh, okay, that makes sense.
Does that make sense? Sorry, I jumped ahead.
Oh, no, you're all good. It just took me a moment. Okay, so this is equal to square root of 15. So that'd be cosine the angle is equal to square root of 15 over 4, right?
Oh, sorry. Yes.
Okay.
Good. Next one. Last one on this section.
Oh, wait, one more question. So on number 3, he specifies that the angle is in the second quadrant. So in the second quadrant, all the cosines are negative. So does that mean that our answer needs to be negative?
Yeah, I think it does.
Okay. Does he even say? Like,
No, in the answers, he doesn't even have it.
that's weird. Okay. Last one. Find without using a calculator.
Okay.
So the arc sine, well, the inverse of root 3 over 2 is what? Oh, also, I was wrong last time when I was
Uh-huh.
talking about inverses.
Uh-huh.
I realized that, okay, one sec. Oh, that's not what I wanted to happen. Jeez. So for sine, the inverse of sine will deal on this side of the unit circle.
Okay.
The cosine will deal with the top half. And then tangent also is on the right side. So I don't know why I was thinking that sine was on the top, but I was wrong about that. I'm sorry.
No, you're okay.
This means that for this problem, the arc sine, the inverse of root 3 over 2 would be pi over 3.
Yep. Pi over 3, but then you multiply that by 2, so it's 2 pi over 3, yeah?
Yes.
And then you find the cosine of that,
Um,
which would be negative 1/2.
awesome. I think that's what he got as well.
Just from using the unit circle.
Yeah.
Cool. That one was easy.
Yeah.
Okay, now we get to do the fun quiz.
Woo! I am so not excited, but that's okay.
I know. I feel like the quizzes are hard.
Yeah.
I feel like I get to them and I'm like, I feel like I didn't do a problem like this.
Yeah. Okay, identify the length of the period for each of the trigonomic functions.
Sorry, mine's still loading. Okay. So for all 6 of them?
Yeah. So we know that sine and cosine is, it should be 2 pi.
That's the ones that you were telling me before, right?
Yeah.
And then tangent you said was pi
Yeah.
and cotangent.
Yeah, so, and then CSC is the opposite of sine, so
Let
I'm
me
not
just
too sure
keep
what that'd be.
flipping it.
Yeah, okay, so for CEC and CSC, I can't pronounce them because I just spelled them out. They're
Okay.
also both 2 pi. And then cotangent is pi.
Okay, so we know that. That's good.
Yeah, it is good. Okay, and then second question, identify which quadrants each of the 6 inverse trigonometric functions are defined.
Oh, sweet. Didn't we just talk about that?
Yeah. Okay, so sine is the right side.
No, 1 and 4.
The what?
Quadrants 1 and 4, right?
Yeah.
Okay.
I was just doing the right side. It's probably better to say quadrants.
Well,
Quadrants.
they identify the quadrants.
Cosine is top, so it's 1 and 2.
Uh-huh.
Tangent is 1 and 4. I don't know I couldn't find where CNC and CEC and cotangent were,
Is
but
it, are they the opposite or are they just the same as those ones?
I'm
Huh.
not too sure because they're like 1 over whatever. So we're allowed to use our textbook on this.
Okay. I have a yes.
But I don't know if it ever says which side of the unit circle to use.
Well, you told me that cotangent and tangent were the same, right?
They're the same for the period.
Well, if their periods are the same, wouldn't their quadrants also be the same? Or no?
I don't know because like it may just be flipped. Maybe flip for that. I don't know. Is there a way to check? Like,
I have zero idea.
okay, I'm just gonna see something real quick. Okay. Hmm.
I'm just looking in my resources instead.
Okay.
I don't know though.
Every time I try to do the inverse cosine of 90, it gives me an error.
Really?
Yeah. I'm gonna go ahead and see if it gives me the same error for like 270. Okay. Let me try a number that isn't 0. 180. Okay. I'm just getting errors.
That's actually a really good idea because then you would know what it's between.
Mm.
Could you just think of, are we still on number 1?
We're on number 2.
Okay. We don't need anything else for number 1 though, right?
Nope.
Okay. Yeah. Maybe.
Huh? Okay.
So I'm thinking, so I went ahead and did the inverse of -1/2, and what it gave me was 60. Wait, no, it gave me a 120. And I did positive 1/2 and gave me 60. So I'm thinking that it will be only for, oh wait, actually, just kidding, let me try, this is what, the wrong thing I was trying to find. One moment. Okay, I'm thinking that secant and cosecant are, well, at least secant is in the top, the first and the fourth, the first and the second, and then I think it's just the same, much like the periods were the same.
I'm good with that if you think, because that's kind of what I was thinking. If the periods are that way, then wouldn't the quadrants be the same? Because the period is from like here to here.
Yeah.
So that's what I'm assuming.
Okay, well, it makes sense. I just wish that there was some resource that like specifically said this is this.
Right.
Okay, graph y equals 1/2.
Okay, we can do this.
I believe in us.
This graph's going to be different because I'm just looking at it generally, and it's like you're going to go to the left 3 pi.
It's not
Going to
fun.
change things up a little bit.
Yeah, seriously. Okay. I'm going to draw out my own graph. That is a real pen. Okay. Oh. So we first need to factor out the
Factor out the 1/2.
yes. And then what is 3 divided by 1/2? Well, 3 pi divided by 1/2. That's 3 pi over 2. That's a fun number. and plus 4. So that means that a is equal to negative 1/2. So that means that things are going to shrink by 1/2. And b is equal to 1/2.
I'm just wondering if it's 3 pi over 2. If you pull the half out.
Yeah, it is.
3 divided.
Yeah, so c would be 3 pi over 2.
Okay.
And then if you do 2 pi divided by 1/2, it should be pi,
Mm-hmm.
and d is equal to 4. Okay. Here's the fun part. So if the period is pi,
Maybe just graph it like with pi halves, pi, you know what I mean? Like go in halves. So pi halves, pi, 3 pi halves, 2 pi. Maybe doing it that way.
yeah, let's go ahead and do that.
I don't know.
Well, yeah, I'm
Or you
really
could do
yeah, because what is, yeah, okay. Yeah, this is great. So it actually be moving to the left again. Oops. Okay, so starting point is moved over to the left by 3 pi halves. And then it is
gonna go up 4.
1, 2, 3, 4. So
Such a random starting point.
yeah. Yeah, it really is. And then let me see. So cosine, usually it goes down, but now it will go up because
Mm-hmm.
it's inverse.
And then we'll go to the inverse.
Yeah. And it has gotten squashed by 1/2. So instead of being in between 1 and 1, it'd be between this point, which is 4.5 by 3.5. So
So the line is gonna be fairly squished. I don't know how to see that.
maybe I should have made it so small. Oh well. Okay, so period starts there, and then it's
And
pi.
And you know that the one of the points is going to be like, well, maybe not. You know that the one point's going to be negative 2 halves and 4, so I got that point. And then we know that the period is going to be pi. So if the period is pi, then you would move over to...
Would it be negative pi halves?
Maybe even 0, actually.
Oh wait, I just realized something. Doesn't cosine start at 1? Like, am I thinking that? Like, it was kind of weird.
What cosine starts at?
second. Where is it? Yeah, because cosine starts at 1 and then goes down normally.
I'm looking.
See, where did it go? There it is. So this is cosine x usually. So if we want to take it to the right and then up,
Yeah, you're right. It starts at 0.01.
okay.
Okay, so now from there, then we would do that.
Yeah. Wait, what is that? Oh, come on. So instead of being instead of being here, it would be at 5. Is that what we're looking at?
Hey, you mentioned that. Okay. I forgot to ask, I guess, I can ask you this one. Did you hop on and see if you do
Yeah, I think so. Because you'd start at 1 and then you would go over, so negative 3 pi halves is in the same spot. And then you're going to go up 4, which would equal 5. So I think that's where it would be.
Okay.
These graphing ones just get me. I like question myself.
Yeah. Like, is this really it? Or am I just imagining it?
Like when I look at a graph, I can usually tell what has happened, but I have a hard time creating a graph.
Yeah. I feel like most of the time I'm pretty much okay, but I always have to check myself on a calculator.
Mm-hmm.
But
Can we use the graphing calculator on this?
we should be able to. I mean, he doesn't say not to.
Okay.
I'm doing it right now.
So is that where that first point is, or is it on the other one that we just had?
Here, let me show. Let me show you. Okay. Let me see. So it is negative 1/2. That's 1/4.
Cosine.
Negative 2. Yeah. Plus 3 pi.
Plus
I'm struggling.
You're okay. I don't care.
Okay. I'm glad. Okay. So there is a point at negative 2 pi. What were we saying? Is this right? I feel like there's something off.
I know. Because I just plugged it in the same. So I just did it too. And it came up with some like a graph that was different than that graph.
Yeah. So 2.
Because I plugged it in with when we pulled out the 0.5.
Yeah.
And it was different.
Yeah. It's even when I plug it into my calculator, it's different. What did I do wrong here? Let's see.
It's like really similar, but it's not quite the same.
Okay, so if we do 3 pi over 2, let's put that in. Hmm. So this is more of what we've got.
Yeah.
Though it's not at the points that we have. And this should be the same
Yeah,
as,
I didn't get that. I have the exact same thing plugged in, and then it doesn't look the same.
I wonder if I was looking at the wrong line. Okay,
Maybe because you take the parenthesis off after the 4 and see if it
Oh.
doesn't.
There you go. Yeah, missed that. There you go.
There you go. That's what my graph shows. When I
Okay,
put
cool.
that in, that's what it shows.
That's good because I think that's right. Just gonna try to figure out why. It shouldn't be different.
I know, that's why I'm wondering if we have like the period wrong or if we have something wrong.
Okay. So
But I
if you
don't know what it would be.
well, it has to be when we pulled out B.
The equation is what?
It has to be when we pulled out B because man.
What was B again?
So B we have B as 1/2. And originally the equation was x over 2 plus 3 pi.
Just in your calculator, do 2 divided by 0.5.
It's 4. So
if that's 4, then that would mean that when we pull that out,
okay. Is B supposed to be 2?
right? And see,
No.
same. No.
Well, okay. Hold on a sec.
It's like not an amplitude shift, it's just like a right and left shift. That's why it's throwing me off.
Yeah. Because if we were trying to take 1/2 out, then of course it would affect C. So what is 3 pi divided by 2? That's okay. Continue.
3 pi divided by 2?
Yeah, that's. Oh wait. Okay.
Uh, 3 pi divided by 2 is just 3 pi halves.
Yeah, it's the same as 3 pi divided by 1/2, which is weird, but okay. I am so confused.
Would it actually be 6 pi? Because 3 pi divided by 1/2 is actually, would it be 6 pi?
You were right. Yep, that's exactly it. Now they match up. Okay, so in our equation, this needs to be 6 pi. Okay.
Okay, hopefully that will work now.
Yeah, hopefully. That'd be nice. Go ahead and get rid of these. Okay, so if it's shifting over 6 pi instead, I don't know if that makes our lives any easier or not, but I'm going to go ahead and erase all this because creativity.
Would it just shift over to pi halves?
Wait.
Oh, sorry, you erased the graph.
Yeah. I thought I'd go ahead and erase it.
Go ahead.
Okay. So originally I had 2 over pi, spinning pi over 2. Oh man, this is gonna get.
That's why I'm wondering if we should just do like, yeah, pi, 2 pi, 3 pi. I've never
Doesn't
done
make
this
it
one
too
this
bad.
big, I feel like.
Okay. And then 4, 1, 2, 3, 4, 5. Okay. So our first point is there.
Okay, so we know that.
Awesome. 1 point down.
And then we know that
The period has to be in between. Oh, come on, it worked.
Are you ready? 518,
About
61,
here.
1947.
Nathan, can you go in a different room, please?
1947. Yeah, have a good day.
Okay. Oh wait, that was wrong. It was gonna be a twin graph again. Oops. Okay, so it will need to be in between -6 pi and -5 pi. And so would that make
It's just confusing.
okay. So we know that the period is 1 pi, which means that it would be in between -6 pi and -5 pi. And then because we have this negative here, I mean the -1/2. Yeah, it's inverted, and it's squished by 1/2, meaning that instead of 1 -1, it is 1/2 and -1/2.
Uh-huh.
And so this is 1, 2, 3, 4, 5. This is 5, 4.5, and 5.5. Then we know that period has to start here and will end here. And I just plotted this line in the middle because that makes sense to me. You have to have it cross this line. And yeah.
Okay, I think we're good then.
Okay.
I don't know, that was pretty for a loop. Okay, the other ones. So these ones are pretty easy, actually.
Yeah. Okay. So
7 pi over 6.
Let me see. So what would A be if it's 7 pi over 6?
So tangent equals sine over cosine, right?
Yeah.
So on the unit circle, 7 pi over 6, that would be negative 1/2 over negative square root of 3 over 2. Something like that. So I think it would be 1 over square root of 3.
Okay. 1 over square root of 3.
I don't know. Do you think that's right?
Well, I can check you in a sec.
Just because if I look at my unit circle,
Yeah.
it's sine comma sine, so it would be 1/2 over, and then you flip it. Yeah, I'm pretty sure that's it. And they're both negative, so that would equal positive. So I think it's 1 over square root of 3.
Okay, cool.
Okay, number 2. Or not number 2, but you know what I mean.
Yeah.
Cosecant negative 5 pi over 4.
See, what would that be?
Okay,
Okay.
so negative 5.
Where is that?
It's at 225 degrees.
Okay. Oh, it's a negative though.
Yeah, so I'm wondering if, because it's a negative, do you find a coterminal angle? Like you do plus 2 pi. You know what I mean? Do you do that on the?
Yeah. I think you do. That would make sense.
Okay, so then you would have 3 pi over 4. So you're trying to find. So essentially, you're going to have 1 over whatever a sine is at 3 pi fourths. You're going to have.
Yeah, it's at 135. That
2 over square root of 2.
Yeah, would that be -1?
No, I don't think so because
Oh, just kidding. Sorry, I was thinking of tangent.
if it was tangent, then yes, it would be.
Yeah. Yeah. Maybe 1 over square root of 2 over 2. I got square root of 2.
Okay,
Yeah.
so I have cosecant equals 1 over sine, right?
Yeah.
And sine at 3 pi fourths equals square root of 2 over 2. So I still got 1 times 2 over square root of 2. I still got 2 over square root of 2.
Okay. Now I'm confused.
How did you get square root of 2?
So I did 1 over square root of 2 over 2. And I
Yeah.
got square root of 2.
So I did the same equation. I just think we're thinking of it different. So 1 over square root of 2 divided by 2.
Yeah.
So to get square root of 2 over 2 on the top, you have to times it by itself on the bottom and on the top.
Okay.
So let me see. I'll just plug it in my calculator and let me see if I'm doing it totally wrong.
Because this is literally what I'm doing on my calculator.
So just plug in 1 divided by square root of 2 over 2 on your calculator.
Okay. Now I'm getting square root of 2 over 4. I'm so confused.
Okay, so you have 1 over, this should not be this hard.
I know.
1 over
Okay.
square root of 2 over 2.
Yeah, I'm thinking that I'm doing it wrong. Okay. Can you just show me what you're getting on your calculator? Do you have a handheld one or?
Well, let me see. One second.
Okay.
Okay, so this is what I have so far. Right there. So
Okay.
see how I divided it to get that bottom number on the
Yeah.
top?
Okay. I'm just confused, like, why we're not getting the same answer in the calculator.
Let's see the calculator. 1 second. My husband's gonna go get me the other calculator.
Okay. Because in my mind, it just doesn't make sense why. Oh, where'd it go?
I think it's because it's 1 divided by that, and so all you have to do is you flip the denominator and the numerator.
Oh,
Does that make sense?
okay.
That's what I'm thinking.
Because I'm just wondering why. Okay, so you got 2 over square root of 2.
Yeah.
Okay. Okay, that does make sense. I can get on board with that.
Okay, I'm gonna look at my calculator, but okay.
You know what? When I plug in 2 over square root of 2 into my calculator, I get square root of 2. So you're actually right. I was just getting it in a different form.
Oh, interesting.
Yeah. I found that the calculator is kind of weird when doing square roots. So
Okay, so I think that would be it then. It's just 2 over square root of 2.
yeah. Okay,
Okay.
and then hey, moving on. So the inverse of negative pi over square root of 3 over 2.
So we know that you said that sine is only going to be in quadrant 1 and 4, right?
Yeah.
So negative square root of 3 for sine is going to have to be in quadrant 4.
Yeah.
So it's going to be 5 pi thirds.
Oh wait, no, because okay. I feel like when it comes to maybe I'm wrong. Actually, never mind. I'm thinking of something else.
Okay.
Okay, so it's 5 pi thirds. And then for D,
You said cotangent is also in quadrants 1 and 4?
yeah.
Okay, so if it was tangent, so then it would be 1 over negative square root of 3. So that only equals 1. So I think it will be, so it's either going to be 11 pi 6 or 5 pi thirds.
Okay. How
But
are
I
you getting that?
So, okay, so first of all, we know that cotangent in this thing, cotangent is going to be negative pi over thirds. No, no, scratch that. Okay, cotangent on the problem is negative square root of 3.
Yes.
So it's negative square root of 3 over 1. So we know that tangent would be flipping those two. So tangent would equal 1 over square root of 3.
Okay. Okay, I gotcha. So
then you'd have to, so you'd look at your unit circle. And
Yeah.
on here, you're like, okay, tangent equals sine over cosine.
Yeah.
So what sine over cosine is going to give me negative 1 over square root of 3?
Okay, I think it's 5
If
pi
I
over
do-
3.
What did you say?
I'm pretty sure it's 5 pi over 3. Let me just check though.
I think that it's actually 11 pi over 6 because you have negative 1/2 divided by square root of 3 over 2.
Okay, I'm just gonna go ahead and check real quick. Okay, so sine over cosine. Okay, so 11 pi over 6 gives us negative square root of 3 over 3. I wonder, can I just put this in my calculator?
Honestly, I was pretty confident about this one. I'm going to write it down and then show you.
Okay.
Okay. So this is what I did. So I know that cotangent equaled that.
Okay.
So that means that tangent equaled that.
Okay.
And then, sorry, I have to look what I did. And then I looked at 11 pi over 6. And that has, it has cosine equaling square root of 3 over 2 and sine equaling 1 over half,
Okay.
or 1 over 2. So then what I did is I was like, okay, well, I know tangent equals sine over cosine. So I did negative 1 over 2 divided by square root of 3 over 2.
Okay.
So
I
then
see
I
that.
have to take the reciprocal, and then the 2's cancel out, and I'm left with negative 1 over square root of 3.
Okay. Could you actually take a picture of that and send it to me just so I can include that?
Yeah,
Awesome.
sure can. But I think that's what it is.
Okay. So it's 11 pi over 6.
Okay, I just sent it to you.
Awesome.
Okay, is that the last one?
Yes, that is it.
Okay. Do you need any more help? If not, I'm going to run really quick.
Okay, cool. Well, I will see you next week.
Okay, thanks.
Bye.